All right, we are on 8-2's homework, and we're starting with number 1. So we have 18 raised to the 5th times 18 raised to the 4th. They want us to write this product as a single power, so we're not going to write this in standard notation or base 10 with the actual full number. Obviously, 18 to the 5th power is going to be really big times another really big number. So we don't want that big long number. We're going to write this just as a power. So with an exponent, anytime we multiply two powers together that have the similar base, we can simply add the exponents. That's what we're covering here in this unit. And so we're going to keep the base, and we're going to add the exponents. And 18 to the 9th is the same as 18 to the 5th times 18 to the 4th. Okay, so similar base, they can combine, and we are simply adding the exponents. Okay, number 2. Same idea. Similar base of -7, so I'm going to keep it. And when I multiply them together, the exponents simply add. So the mistake would be to put 6, but it is 5. Okay, number 3. Write w to the 4th times w to the 3rd as a single power. Let's do that first. That's w to the 7th, just adding them. Check your answer by substituting 2 for w. So we're going to double check it. If we go back to the original, 2 to the 4th times 2 to the 3rd. Okay, if we do 2 to the 4th, that's 16. 2 to the 3rd is 8. And 16 times 8 is 128. So if we substitute 2 into the original, we get 128. We want to see if w to the 7th is equivalent. So we're going to do 2 to the 7th. And sure enough, we get 128. So substituting the 2 in proves that this property holds true. When you're multiplying two similar bases, you add the exponents. All right, skipping down all the way to number 8. We're going to rewrite this as a single power. So again, not standard form, writing it with a power. So we're starting off with 2 to the 3rd and raising that to the 4th. And just a reminder of what this actually means, you're multiplying it 4 times. 2 to the 3rd is what's being repeated 4 times. So 2 to the 3rd is 2 times 2 times 2. That's 2 to the 3rd. Now that whole quantity is being multiplied 4 times. So there's 2, 3, and 4. So if you actually counted it up, how many 2's we have all the way across, 2 times 2 times 2, there's going to be 12 of them, and we can see the correlation. If we raise 2 to the 3rd to the 4th, when you raise a power to a power, you multiply these. So this is 2 to the 12th. Now, you don't have to show all this every single time. Just want to make sure that we're reinforcing this, not just memorizing that you multiply here, you add here. Let's make sure we understand why it works. Okay, number 9. M to the 5th raised to the 2nd holds true to this property. You're just going to multiply your exponents. So this is m to the 10th. Y to the 2nd raised to the 6th, multiply your exponents. That's y to the 12th. Okay, number 11. Simplify the power. So we have 3a to the 4th times 5a to the 2nd. So this is where it starts to get a little confusing for students because they're used to now adding things together, even though this is multiplication. That is true for the exponents, but you don't all of a sudden start adding the whole numbers, the coefficients. This is 3a to the 4th times 5a to the 2nd. So regular numbers still multiply like regular numbers. This is 15. But when you're multiplying the base times the base, that's similar. You add the exponents, so this is a to the 6th power. So 15a to the 6th. 12. Order of operations says take care of exponents first. So I'm going to go ahead and leave the 2 alone out front. When I multiply here, this is going to be k to the 70th. And if you wanted to keep it in parentheses, you could. The 2 basically is distributed to the coefficient of 1 here, and so it's just 2k to the 70th. Okay, no powers raised to a power here. This is d, which is d to the first. So when I multiply times d to the 13th, similar base, add your exponents. This is d to the 14th. All right, we got a lot going on in this one. We can only multiply similar bases together. Other ones are going to drop off. Now you can leave the a to the 0, multiply times the other a, adding your exponents. So it's still going to be 9. 0 plus 9 is going to be 9. We also know anything to the first power is just 1. So 1 times anything is just going to leave what you got there. Okay, so this is going to be a to the 9th. I'm going to put the a's up front. Your answer key had m's in front. Normally you put it alphabetically, so I'm going to put a up front. This is going to be times, which you don't even have to write the times symbol. You can just put these next to each other. So it's going to be m, and we're doing m to the 2nd times m to the 9th times m to the 7th. So if I put those all together, that's going to be m to the 18th, just adding straight across. 15. We're sitting next to parentheses. This is multiplication. Okay, it multiplies towards this whole thing. And so the b is just going to be left alone. The a times the a is all we can combine here. And we're not bringing it in and multiplying. We're not raising this to a power. We're just multiplying the actual power times a power, which means you're adding the exponent. So this is going to be a to the 8th. And the b to the 3rd is just tagging along. There's no other b for it to multiply with. Cannot combine those. 16. Okay, in this one you're going to want to deal with your exponents first, power raised to a power. So I'm going to leave 4k squared alone. K to the 3rd raised to the 5th, that's k to the 15th. And now when I multiply these two together, I'm going to add my exponents. 4 is just going to hang out in front, so it's 4k to the 17th. Okay, now go into the applying section, so we'll take a little bit further. So your quiz has 2 parts. The first has 5 multiple choice questions. The second part has 3 multiple choice questions. Each multiple choice question has 4 choices. How many different sequences of answers are possible on the 8 questions? So the first part has 5 multiple choice questions. 1, 2, 3, 4, 5. And then the next part has 3. All of them have 4 choices. 4 choices here, 4 here, 4 here, all the way across. Okay, that gives us a total of 1, 2, 3, 4, 5, 6, 7, 8. So this is 4 to the 8th power. And so when I raise 4 to the 8th, I get 65,536 different combinations. All right, we're jumping to 18. We've got 2 to the 4th times 2 to the n, and we know it equals 2 to the 12th. Now, you could probably do this in your head. We know that when we're multiplying similar bases that the numbers are being added, so 4 plus something got me 12. You could probably figure that out. It does say show all work, so we're not doing anything with the 2's. Once we understand that these are being multiplied and we're adding the exponents, we really just need to work with the exponents. So we know that the 4 is being added to n, and it's coming out to 12. So if I'm showing my work, I'm just going to write this quick as an equation, and n equals 8. If I had an 8 here, 2 to the 4th times 2 to the 8th, you would add the exponents, you get 2 to the 12th. Okay, 19. 5 to the 6th is being raised to the x, and it equals 5 to the 6th. We know that a power raised to a power, you multiply them together, so 6 times something got me 6. We know it's 1. We're going to write that out. 6 times something equals 6. Dividing by 6 to clear this out, and x equals 1. 20. In parentheses, a to the 7th times a to the n. That is raised to the 2nd and equals a to the 24th. So we kind of got to reason through this a little bit. All of this is going to be combined, right? You're going to have 7 times, you're going to have 7 plus the n because we're multiplying these two together. So you're going to add 7 and n, and then that number is going to get multiplied by 2 to get 24. So we know that that's going to have to come out to 12. Therefore, 7 plus what is 12? Okay, it's 5. But what we're going to do is we're going to say, okay, we know it's 7 plus n being added together. That answer is going to get multiplied by 2, and it's got to equal 24. So if we're writing it out as an equation, this is what it looks like. 7 is being added to n, that's being times by 2, and we're getting 24. So a couple things. You could distribute here if you wanted to solve it, or you could divide right now by 2, and that's what I'm going to do since this is being multiplied. That'll cancel. You have 7 plus n equals 12 minus 7, n equals 5. That's one way to show the work. Or again, you could have distributed, and you would have had 14 plus 2n equals 24. You would have minus 14 on both sides and got 2n equals 10. Divide by 2 on both sides, and n equals 5. So 2 different ways to show your algebra there. Okay, this is showing that you understand at a higher level than just being able to reason through it. So being able to set that equation up and solve is important. So 21, we have a population, which we're going to call P. We don't have a number, P, of bacteria triples each day. Write an expression for the number of bacteria after 4 days. So we're going back to our B times G to the X formula, because it's tripling every single day. That's exponential growth. So our beginning is how many bacteria we started with, which we don't have that number, but we have P to represent it. So P is going to go in for our beginning number. Our growth factor is 3. And it's being raised to the amount of time, which is 4. The 3 comes because it's tripling. So that's letter A. And so how many days after the 4th day will the bacteria population be? P times 3 to the 20. So the 20 just means it's day 20, right? The 4 means it's day 4. So how many days after day 4 is day 20 is really all they're asking here. They want you to be able to recognize that this equation is telling you it's day 20. And so therefore, if it was day 4, then 16 days later, we are here at day 20. All right, after 21, we skipped to 23. So she's going to buy a new car. She's got to choose the body style. So when she chooses the body style, she has a sedan, an SUV, or a convertible. That's 3 choices. She's got to choose the transmission, automatic or standard. Standard is a stick shift. And color. 1, 2, 3, 4, 5 different choices on color. So these are the 3 decisions she has to make. 3 choices, 2 choices, 5 choices. So how many different ways can she make her choices? You could have a sedan that's an automatic and white. You could have a sedan that's standard and white. You could have an SUV that's automatic and white, so on and so forth. So instead of actually writing those all down, we can just multiply the number of choices for each one, and that's going to give us our answer here. So 3 times 2 is 6, times 5 is 30. So letter B, if another choice of silver is given to her, how many more choices does she have total? So that means there's still 3 choices on the car shape. There's still 2 on the transmission. But now instead of 5 colors, there are 6. If I go ahead and multiply that all the way out, this one equaled 30. 3 times 2 is 6, times 6 is 36. And the answer is not 36. Okay, because they're asking you how many more choices does she have. So now she has 6 more choices. So just be careful on the wording of the question there. They're not asking you how many choices, it's how many more choices, so it's 6. All right, some review here on 24 from Chapter 7, function notation. I'm going to go ahead and write these down. F of x is 3x plus 2, and g of x is 3x squared minus 2. So for letter A, we're going to find f of 3, which means we're plugging directly in here. So it's 3 times 3 plus 2. So that's 9 plus 2. So that answer is 11. Part B, we're finding g of negative 2. So plugging right in, this is 3 times negative 2 squared minus 2. We talked about this on the test. You got to be careful. Don't plug negative 2 squared in without parentheses. You should be able to just do this in your head. Negative 2 times negative 2 is 4. This becomes positive 4. So it's 3 times 4, which is 12, minus the 2, which is 10. Okay, part C. Let's slide this over a little bit. Part C, we're going to do f of 5 minus g of 5. So that means we actually have to find both of them. So first, let's find f of 5. That's 3 times 5 plus 2. So that's 15 plus 2, that's 17. And then g of 5, that's 3 times 5 squared minus 2. 5 squared is 25. 3 times 25 is 75. Minus 2 is 73. And so we're actually going to do 17 minus 73, f of 5 minus g of 5. And that comes out to negative 56. And then letter D, going to have to go to a new page here. We've got g of negative 4, and we're going to add f of negative 4. So first we have to find g of negative 4. Okay, so that comes out to 3 times negative 4 squared minus 2. Negative 4 squared, negative 4 times negative 4 is positive 16. So it's actually going to be 3 times 16 minus 2. That comes to 46. Okay, so this is 46. And we're going to add f of negative 4. So f of negative 4, plugging that one in. 3 times negative 4 plus 2. So 3 times negative 4 is negative 12. And we're going to go ahead and add 12. And so that's going to be 0. And so this comes out to 0. And so when I add those together, I'm going to get positive 46. And just notice that doesn't match the answer key, right? So there's a mistake in here. Looking quick, when I wrote this one down, I wrote minus 12. I'm sorry, I put plus 12 instead of plus 2. So that definitely changes things. So instead of negative 12 plus 12 to get 0, it's negative 12 plus 2. So that's negative 10. So this is not 0, this is negative 10, which is going to knock this guy down to a 36. So answer key was right there. Silly mistake. All right. We are jumping to 26. Considering this line in y equals mx plus b form, find the slope, always attached to x in this form. Find the y-intercept, it's negative 5, and find the x-intercept. So that was really easy until now. So we want to find the x-intercept. So the x-intercept, if you think about a graph, where a line crosses the x-axis, what's the y value? It's not positive, it's not negative. The y value is 0. So if I want the x-intercept, I have to plug 0 in for y. So 0 equals 4x minus 5. And I'm going to solve that. Because again, no matter where this line crosses, the x-intercept, no matter what this looks like, is when y equals 0. That's what makes it the x-intercept, because it's not up here, it's not down here, it's hitting the x-axis. Anywhere you are on the x-axis, the y value is 0. So we plug 0 in for y, we're going to solve for x. So adding 5 to both sides, dividing by 4, be careful, divide by 4 to get rid of it. And so x equals 5 over 4, which you technically could leave, or you could turn it to a decimal by dividing, and that's 1.25. So 27, we're going to put this into scientific notation. We have 2 zeros, 3, 2, 4. So to put this into scientific notation, the decimal is going to have to go between the 3 and the 2, because our lead number needs to be between 1 and 10. So 3.24 times 10. Now this was a really small number, so this is going to be a negative exponent. And how many places did we move it? 1, 2, 3 places. So it's negative 3. And there's our number in scientific notation. All right, and last question, number 28. We're going to write all these numbers as decimals. So 9.8 times 10 to the 0. Well, 10 to the 0 is just like 1. And so this answer here is just 9.8. Part B, 9.8 times 10 to the negative 1. So if it's to the negative 1, it means it's representing a small number. So we have to shift it this way and make the number smaller. And so that's going to equal 0.98. I shift it one spot. Letter C, 9.8 times 10 to the negative second. So again, a negative means we are shifting it left here to make it a really small number. One spot gets it in front of the 9. We got to go 2 spots. So one more spot means I'm going to add 1 0. So it's 0.098. And then letter D, 9.8 times 10 to the negative 3. So you can see we're just moving one spot to the 0, to the negative 1, to the negative 2. So just by following this order, we should have 2 zeros here. And the reason is we shifted one spot here, 2 more spots to move it, 3 spots total, and it's 0.0098.